All right, so we got a pretty standard mirror problem here. Somebody's looking at themselves in a metal sphere. Okay, the sphere is 60 centimeters in diameter, and the person is 4 meters away. And the question is, what is the magnification of the image that they're seeing? So first up, we got to figure out what information we have. We have DO is equal to 4. And I'm going to make it 400 centimeters. Because I'm going to want everything in centimeters for this stuff, because one of the other ones is already in centimeters. Doesn't matter, you just got to have them all in the same unit. Now, we don't have the focal length. We have the diameter is equal to 60, which means the radius is equal to 30, which means the focal length is equal to 15. Except it's not 15, because this is a convex mirror. Okay, the focal point is behind the mirror surface or inside the sphere, which means that it is negative 15, and that's pretty darn important right there. So with that, we can then use the mirror equation, okay? And we get that 1 over negative 15 equals 1 over 400 plus 1 over di. From that, we should get that di is equal to negative 14 point. Actually, I'm going to solve this out here a little bit. So the first step here would be to multiply through by everything. Okay? So we could actually multiply through by all the denominator values. All right? So we would get 400 times di times negative 15 over negative 15 equals negative 15 times 400 times di over 400 is equal plus negative 15 times 400 times di over di. Now obviously we can cancel some of that out. So we get the negative 15's canceled out, the 400's canceled out there, and the di's canceled out here. We then get 400 di equals negative 15 di, okay, minus 6,000. Okay. We then solve for di, and we get that di is equal to negative 14.46 centimeters. Once we have that, though, that is not our answer, but we are only one step away. We can come back and we can say, okay, the magnification is equal to either hi-ho or negative di-do, which means negative 14.46 over 400, and we should get a magnification of 0.036. All right, that means it is 3.6% as big as it was initially. Also, because it is positive, it means that the image is upright, which also makes it virtual.